Well, good morning, everybody. Lesson 108, Square Roots Revisited and Radical Equations. I love this lesson. I wish you were here. I could be all excited about it. I can still be excited. It's just not quite the same teaching to an empty room. But I'll just pretend that you're all here. It's all fun and all that good stuff. Anyway, you want to turn to page 454 and you want to read through this. It would be helpful. And you'll notice that in the little box, it reminds you that the square root of x getting squared is x. And we've talked about that. Anytime you square a radical, the radicand, the thing underneath the radical, comes out. And they have several examples. I have square root of 5 getting squared is 5. And the square root of a binomial, x plus 2, under the radical, the x plus 2 comes out, okay? Let me just adjust this just a little bit so you guys can see it. All right, so this is what we will be using to solve equations that have radicals. Now, I'm going to do the first example. We have x minus 2 plus 3 equals 0, all right? And we want to solve for this x. So the first thing we want to do is isolate the radical. Okay, we want this by itself because it has the x. So we want to get rid of this 3, so we're going to subtract it, okay? So we'll have radical x minus 2 equals negative 3. See what I've done? Subtracted it, right? Now, I'm going to square both sides so that the radical comes out, all right? Whatever I do to one side, I'll do to the other, okay? So x minus 2 will come out. I've squared the radical. The radicand comes out. Over here, negative 3 getting squared is 9. Okay? Now, I want to solve for x. I'm going to add 2, and I get x is 11. Now, with these, it is imperative that you check your answers because sometimes you're going to get an answer that doesn't work. In other words, something that's not true. So let's plug this in. So 11 minus 2 is 9. The principal square root of 9 is 3. 3 plus 3, that's not equal to 0. So this has no solution because that x did not work. And again, when we're talking about when we plug in a value, we're going to take out the principal square root. Okay? So 3 plus 3 is not 0. All right, let's do another example. Let's look at 108.2. So in this one, we have x minus 2 minus 6 is 0. All right, so just like last time, I'm going to add the 6. I want to isolate my radical. All right, I'm going to square both sides. I get x minus 2 equals 36. I'm going to solve for x by adding 2, and I get 38. So it's pretty fun and easy, isn't it? But now we got to check it. So 38 minus 2 would be 36. The principal square root is 6. Minus 6 is 0. This one checks. All right? Very, very good. All right, let's do the next example, 108.3. We have the radical x squared plus 9 minus 5 equals 0. So this one's a little different because the radicand has an x squared. Well, that's okay. We can do this. We're still going to add the 5. We want to isolate the radical. Okay. We're going to square both sides. We get the radicand to come out. Okay, we're going to subtract 9. And now I'm going to take the square root of both sides. And when we take the square root, we have to realize that x could have been a negative as well. So in this case, we will say plus or minus 4 is a possibility here. Now, let's plug these in. Now, think about it. If I squared either negative or positive 4, I would get 16, right? So 16 plus 9 in either case would be 25. The principal square root of 25 is 5. Minus 5, 0. Both of these solutions work. All right. Now, I'm going to go a little bit out of order. I want to do the last example. All right, this one's pretty simple. Not that example 4 is not, it just is a little more time consuming. I'm going to do the easier, quicker one first. Now this is fun when we have radicals on both sides, as in example 5. So what will we do? Square both sides, right? So that's cool. We'll do that, and both radicands will come out. And now we have a very simple algebraic equation. I'm going to subtract the x, correct? And I'm going to add 3 so that these will cancel, these will cancel. I have 1x equals 5. Okay, now plug it back in and see if it works. The square root of 2 times 5 would be 10, minus 3 would be square root of 7. Over here, if I plug in 5 plus 2, I have square root of 7. Sure enough, it works. So those are really fun. All right, now example 4, I wouldn't say it's not fun. It's just a little, like I said, a little more time consuming. So let's look at that one. We have radical x minus 1 minus 3 plus x equals 0. Okay, so we've got an x under the radical and we've got a plain old x. Well, we still need to isolate the radical. So we're going to move these things over, all right? So we're going to have radical x minus 1 equals negative x plus 3. I hope that you see that. Okay? Now, I want to square both sides because I want this radical to go away. Okay? So the radicand comes out over here. What happens here, I'm taking this binomial and square it. So I would suggest that you write it twice so that you're not tempted to just distribute the exponent. Remember, when you have a binomial and you square it, you need to do FOIL, don't you? All right, so let's do that. And we would have x squared, we'd have plus 9, our inside product, and our outside product. Okay, now we need to collect like terms here on the right. All right, and now what we want to do, since we have x squared and x to the first, we want to set this equal to 0. See, what we've done now is put all kinds of skills together. We want to move these over, set this trinomial equal to 0, factor it, and get our solutions. All right, so I'm going to subtract x from both sides and add 1 to both sides. Okay, this will get rid of everything on this left side. So I have 0 equals x squared minus 7x plus 10. Okay, and you've had problems like this, and usually we have the equal 0 on this side. Okay, well that's okay, I can do that. All right, so now I want to factor this into x minus 5x minus 2, and then get my 2 possibilities. So x is equal to 5 or 2, right? 5 minus 5 could be 0, or 2 minus 2 could be 0. So these are my 2 possibilities. Well, let's plug them in. Sometimes both of the solutions will work, sometimes one of them, sometimes neither. Okay, so let's plug in 5 and see if it's true. So 5 minus 1 would be 4. The square root of 4, principal square root is 2, minus 3 plus 5. I'm plugging in 5 for x. Is this true? Is it equal to 0? No. All right, so 5 does not work. All right, let's try 2 and see if it works. Let's plug that in. 2 minus 1 is 1. Square root of 1 is 1. Minus 3 plus, I'm plugging in 2 for x. Is that true? Yes. So 2 is the solution. Okay, I'd like you to stop the video and you do the practice, A and B. I'll put them up here and you come back and check them after you've done them. Okay, so as you see for A, I squared both sides. I got the radicand equals 9. I added 6 and found 15 for my solution. When I plugged it in, I got that it was true, so good to go. On B, I went ahead and subtracted x and added 6. Then I squared both sides. My radicand came out. I wrote this twice and did FOIL. I moved things over, set this trinomial equal to 0. I factored it and found my two possibilities, 7 and 6. When I plugged 7 into the original equation, I did not get a true statement, okay? So 7 was not a solution. When I plugged 6 into the original equation, I did get a true statement. 6 is my solution. All right, so your assignment is in RenWeb. I hope you have a lovely day. I hope you find fun, new things to do. Reading a good book, doing some Sudoku puzzles or jigsaw puzzles, or decluttering your closet, helping your parents with chores, maybe washing the car for them. There's plenty of things for you guys to do. I love you and I miss you, and I'll talk to you soon. Bye-bye.